And welcome to the video lecture corresponding to Chapter 4, Sections 4.8 and 4.9 of Basic Sentential Logic and Informal Fallacies, the text used for Philosophy 10, Introduction to Logic at UC San Diego. The topics of Section 4.8 and 4.9 are 4.8 subproof frames, and 4.9 will be nested subproofs. Now, neither of these topics is, strictly speaking, required. You're not tested on either of these. I highly recommend that you look at the section on subproof frames because they will, I think, make it a lot easier to do subproofs and understand how proofs work. And then the section on nested subproofs, again, you don't need to, but if you feel pretty comfortable with subproofs, then often nested subproofs can make things even easier. So I would recommend looking at that as well. So first off, let's take a look at subproof frames. Now, what are subproof frames? When using subproofs, now it's a way of planning a proof. You can plan the proof using frames, and this can often make the proof manageable and clarify the strategy. So it's just a way of planning basically what you're going to do in a proof that often makes the proof a lot easier. So here's an example. This is a tautology. I don't have any premises to work with. This is what I'm trying to derive. So what I'm going to do is I'm going to sort of work backwards to begin with. I know that the last line of the proof is going to be something like that. Okay, obviously, because that's what I'm trying to derive. Now I'm thinking, how could I get that? Well, I know that if I can get this conditional, okay, where the last component is the same, but the first component is just this, but negated, right? If I can get this, then I can do conditional exchange on this to get that in one step, okay? The justification will just be whatever conditional exchange. I don't know how many lines this is going to be, because this is the end of the proof. So now I'm thinking, how can I get this? Well, this is a conditional. I could use conditional proof to get this, okay? And what I would do is assume the antecedent, assume that, and then try to derive this. So now what I can do is I'm just going to put a little schematic of how this subproof is going to look. I'm going to assume this, derive that. That will then give me this conditional when it's done, and then I do conditional exchange on that to get this. So this is, think of it as a subproof frame. Okay, what it is it's basically I'm planning out how my proof is going to work. Now all I need to do, the only actual part of the proof that isn't done yet, is going from this to that. Basically, how do I derive if A then D? Okay, and that's going to be really easy. I have, well, actually, there's an easier way to do it than I'm going to do it. One way to do it is, well, here, I'll show you. Okay. But before I show you, the rest of the proof itself isn't that interesting. What is interesting and what I want to highlight is this frame, okay, because this tells me everything I need to know about how I'm going to do the proof. I'm going to do a conditional proof, assume this, derive that. That will give me this conditional, which I'll be deriving by some chunk of lines with conditional proof. Then I'm going to turn that into that by conditional exchange. Okay, so then when I go to do the real proof, it's going to look like this. All of this stuff is exactly the same. I'd already planned this out. I assumed this, I derived that, got this by conditional proof, did conditional exchange on line 7 to get that. The only thing I didn't have worked out was this stuff in between here. And the way I did that is I did conditional exchange, then did De Morgan's on that, simplified A or D by DI, and then I did conditional exchange to get if A then D. So that's how I derived if A then D from that. But you can see that the frame itself did most of the work for me there. Let's see another example. So here, this is not a tautology, this is a regular proof. If you look at the conclusion, there's two things here, if X then Y and X or Z. So what I'm going to do is I'm going to do this proof by deriving each of these conjuncts separately and then just conjoining them. So first I'm going to derive this, then I'm going to derive that, and then I'm going to conjoin them. Okay, so how am I going to derive? Let's look at this one first. It's a conditional. I'm going to do conditional proof. So what I'm going to do is I'm going to assume x, derive y. That'll be my assumption for conditional proof, derive y. And then once I've done that, because it's a conditional proof, I'll have if x then y. This will actually probably be line 3 because I'll probably start with that conditional proof. But I don't know how many lines this is going to take, but eventually I'll get y. When I do, I'm going to close this proof off and I'll have if x then y. And the justification will be the whole set of lines conditional proof. Well, then the next part is I'm going to derive this disjunction. How am I going to do that? Well, I'm going to do that with indirect proof. So what I'm going to do is what I'm trying to derive is this, x or y. I'm going to assume the negation of that, not x or y. That'll be my assumption for indirect proof. I'm going to derive a contradiction. I don't know what that contradiction is yet, so I'm just going to put a note here, contradiction. And then once I've got the contradiction, I'm going to have to, the next line will be the negation of my AIP, x or z there. And that'll be through these chunk of lines indirect proof. And I don't know what that chunk is yet because I don't know how many lines this will take. And then, once I've got both of those, I'm just going to conjoin them. So I'm going to take this statement and conjoin them. And then once I do that, that'll be the conclusion, and I'm done with the argument. Okay? So now I know exactly what I'm going to do. The only thing I don't know is the filler here and the filler here. How do I get from x to y? That's super easy. Look at this. If I've got x, I can get y and z by modus ponens and simplify y off. So that's going to be super easy. How can I get a contradiction here? Well, I've got not x and z. If I do De Morgan's on that, I have not x and not z. With not z, I can get x by modus ponens, so I'll have x and not x. That'll be my contradiction. So now I know exactly how this proof is going to work. I just talked through it. So all I have to do is fill in the parts. And this is what it's going to look like. Assume x derive y. Assume negation x or z, derive my contradiction. And then this is exactly how I had it in my frame, right? So all I've done here is I've just filled in the details. Okay. So that's subproof frames. And if you start using those, it makes understanding subproofs and understanding strategy of approaching proofs a lot easier. Okay. Now, the next topic is nested subproofs. So long as the rules for subproofs are followed, right, for conditional proof and indirect proof, a single proof can have more than one subproof, and we've seen examples of that. In fact, the example we just did had a conditional proof and then an indirect proof after that. But we can even have subproofs within subproofs. Okay, so let's see an example. So here's a proof. What we're trying to derive is if D then A. So I'm going to go ahead and use subproof frames for this to just set up my strategy. I'm going to use conditional proof. I'm going to assume D to derive A. So that's what it's going to look like. I'm going to assume D, derive A. Once I've done with that, I'm going to have if D then A, and that's going to be my conditional proof for this whole set of things. So now, of course, this is probably going to be line 3 because I'm going to start immediately with that. At this point, my goal is just going to be to derive A. I've assumed D. I'm going to try to derive A. I can do that any way I want to. I can use inference and replacement rules, or I could use indirect proof. Inside this subproof, I'm trying to derive A. I could assume the negation of that, assume not A, and derive a contradiction. This is what it would look like. So here I started my conditional proof. Inside that subproof, I'm nesting a further subproof inside, okay? Because I'm trying to derive A here, assume D, derive A. I'm going to do that by indirect proof. Assume the negation of A, derive a contradiction. That's how I'm going to get A here. Okay, now I don't know what this contradiction is, and I don't know how I'm going to get from A to a contradiction, but I know everything else in my proof now. I've got the whole structure laid out. Conditional proof, indirect proof, I'm going to derive a contradiction. Then the justification for this is going to be an indirect proof going from whatever this line is, probably 4 to that. And then the justification for this will be the whole conditional proof, line probably 3 to that, whatever that is. Okay. So now it's just a matter of how am I going to get this contradiction? And if you look at it, that's going to be pretty easy. Okay. I have not A, so I can get B and C, and I can simplify C off. I've got D, so I can get not C, so I'll have C and not C together. So now that's all I'm going to have to do is just fill those in. So I'm going to go ahead. I already knew I was going to do that. Assume D, ACP, assume not A by AIP. Now I'm just going to try to derive the contradiction. I already know how I'm going to do it. Modus ponens on 2 and 3 to get not C. Modus ponens on 1 and 4 to get B and C. Simplify C off of line 6. Now I've got C at 7 and not C at 5, so I'm going to conjoin C and not C. There's my explicit contradiction. So I can close that subproof off. The next line is going to be A. It has to be the negation of my AIP. Well, A is what I was trying to get to close my conditional proof off. Okay, so now I can close that. I assume D and derived A. So now I can close that subproof off. The next line has to be a conditional, whose antecedent is the ACP, whose consequent is the last line. Okay, so now you can see how easy using these frames made it, and how easy also using the nested subproofs rendered the proof. Let's do another example. Okay, so here, again, I'm trying to derive a disjunction. I could do this without using any subproofs. However, I'm going to use subproofs. Subproofs almost always make things easier. How can I derive a disjunction? Well, I could derive either disjunct and then get the other disjunct by DI. I could use conditional proof because there's a conditional that I could derive that I could then use CE to get this. What is that conditional? Well, if I want to end up with this, that's my last line. The conditional I want to have is this, right? Because if I can derive this, I can turn it into that in one step. Okay, I just apply conditional exchange to this, and now I've got the conclusion and the proof is done. So now my problem is, how do I get this conditional? Well, I'm going to do conditional proof. Assume that antecedent, derive the consequence. So I'm going to fill in my frame. I'll be assuming C or B and attempting to derive A from that. Okay. Now, you can see that that's going to be pretty easy. I've got C or B. So by dilemma, I can get the disjunction. I can get A and D or A and E by dilemma. And then by distribution, I can pull A out. That'll be the common element of those two disjuncts. I can pull it out, and then I'll have A. So that would be one way to do that. Another way to do it would be to do a nested subproof. I'm trying to derive A. I can assume not A and derive a contradiction. So that would look like this. Nest a subproof inside here, assume the negation of A, derive a contradiction. That gives me A. Then I can close this subproof off, get C or B, then A, conditional exchange to get that. Now, all I need to do is get a contradiction. And that's going to be really, really easy. Let's see it in real time. I know what I'm going to do. Conditional proof, indirect proof, contradiction, A, that conditional exchange to get that. So step one, now I'm going to go through. I know how I'm setting everything up. So there's my ACP. Here's my nested AIP. Now I'm going to try to derive a contradiction. I'm still going to use dilemma on 1, 2, and 3. Why not? Do distribution, simplify the A off, and there's my contradiction. I've got A and not A. So I can conjoin those two, A and not A. That's my contradiction. I'm going to close my indirect proof. Boom. Now the next line has to be the negation of my AIP. Well, AIP was A, so the next line has to be A. Well, that's what I wanted to close my ACP, my conditional proof. So now I'm going to close that off, and I get if C or B, then A, and that's by 3 through 9 conditional proof, which of course I knew I was going to get because I had this all planned out beforehand. And now I'm going to do conditional exchange on that to get the conclusion. Okay, so pretty straightforward. Once you understand how the frames work and how the nested subproofs work, you're good to go. Let's do another example. This is, again, I'm not going to do the frames now, but you can do the frames if you want to. I'm going to do a conditional proof, so I'm going to try to derive if not M, then K, and then I will get M or K by conditional exchange on that. So now my goal is to derive K. Okay, how can I get K? Well, I'm going to nest an indirect proof. Now, of course, you can see you don't have to do that, right? My goal is to derive K. I've got not M. I could get not M or P by DI, then get K and not L by modus ponens and simplify K off. So I could do that. But just for fun, I'm going to nest an indirect proof, not K. Now I'm going to derive a contradiction. That'll also be super easy. Watch. So I've got M on 3. I can get M or P by DI. That's now the antecedent of line 1, not M or P. So I can get K and not L by modus ponens on 5 and 1. Now I'm going to simplify K off. And there's my contradiction. I've got K and not K right there. So I can conjoin those, K and not K, close off my indirect proof. Next line has to be the negation of my AIP, so it's going to be K, which is what I wanted, because I wanted if not M, then K. So now I can close off my conditional proof and write if not M, then K. And then finally do my conditional exchange on line 10 to get M or K. All right, let's do one more example of a nested subproof, and we'll call it a day. Here's a tautology, either not A or B, or not A and not B. Okay, that is a tautology. Now I'm going to do my standard tactic that I'm going to use with disjunctions. I know that every disjunction is closely related to a conditional. I'm going to try to derive that related conditional and then turn it into the disjunction. The antecedent of the conditional I want is A or B, because I'm going to have the conditional if A or B, then this. That's going to be a conditional, and then I'm going to turn it into the disjunction by negating that. Okay, you'll see how that works at the end if that's not clear to you already. So now my goal is just to derive this other component here, not A and not B. Well, conveniently, that is the negation of something, of a conjunction. So I can assume the negation of this, the negation of not A and not B, is just not A and not B. I just take that tilde off of the outside to negate it. Now my goal is just to derive a contradiction, and you can see it's going to be really easy to derive a contradiction because I've got A or B. This says one of them is true. This says A and B are both false. So of course, intuitively, you can see that there's a contradiction here. Now it's just a matter of deriving the explicit contradiction. And I can do that by, I'm first going to simplify off both A and B. By the way, there's a lot of ways to do that. One thing I could do is I could just do De Morgan's right here on line 2, and I would get not A or B, which is the negation of that. And then on the next line, I would just disjoin them, and it would be A or B and not A or B. And that would be an explicit contradiction. So that'd be one way to do it. I'm going to do it a different way here. First, I'm going to simplify A, and then I'm going to simplify B. And I'm sorry, simplify off not A, simplify off not B. Then, because I have not A on line 3, not A is the negation of that first disjunct, I can get B, the other disjunct, by 1-3 disjunctive syllogism. Now I've got materials for an explicit contradiction. I've got B and not B. So I'm going to conjoin those from 4 and 5. Now there's my explicit contradiction. So I'm going to close my indirect proof. The next line has to be the negation of my AIP, which is that. That's what I wanted. So I'm going to close my conditional proof off. The next line has to be a conditional whose antecedent is this and whose consequent is that. Okay. This is why I assumed A or B up here. It's because I want this conditional. Okay, I know most students get this, but some students, this isn't as obvious to some students who still kind of struggle with this. The thing you assume for conditional proof is the antecedent of the conditional that you want. This is the conditional I wanted. Why did I want it? Well, because I know that I do conditional exchange on this and I get my conclusion. So that's why I wanted this. Given that this is the conditional I want, this, the antecedent, is going to be my ACP, A or B. Okay, now I'm just going to do the final step. I'm going to do conditional exchange here to complete the proof. Conditional exchange on 8, and now I've actually derived that statement, and the proof is over. Okay, well, that does it for chapter 4.